device code phishing, and especially also in the Azure environment, if I understand correctly. And I'm greatly looking forward to your talk, Felix. Thank you.
Thank you very much. So my topic is device code phishing on Enter ID. It's my favorite phishing method ever, and I think it's highly underrated in the community and also by threat actors. So I also think it quite fits into the topic of the Swiss Cyberstorm, the human factor, because it's a phishing method, we still rely on some human factor going wrong. But to better understand device code phishing, we need to have a little step back to understand the underlying principles that we have. Now let's see if this works. So let's assume your company has telephones like those. They are fully integrated into Teams. You can log into them with your Azure account. Now imagine you have to enter your super complicated password on here. Would be quite a terrible user experience. So for this purpose, they standardized an OAuth 2 flow, which helps you with that problem. And this looks like this. So we have, do we have a laser pointer here? Yes. So we have our user here that has a laptop with a keyboard input, and we have like our phone in here with limited keyboard input. And also in Azure AD or Enter ID, we have this Microsoft Online identity provider, which handles all the authentication. So what the user first does is like, okay, I would like to initiate, I would like to start the login on here. So he pushes a button or whatever. We have the phone initiating the device authorization grant flow. That's what is called in the RFC. And the phone will display some kind of instruction to the user, including a user code. And in the background, our phone will poll if the authentication has already happened or not. So from a user perspective, this might look like this. Sorry for my bad photoshopping. But usually you have like an instruction, go to microsoft.com/device login and enter this user code to authenticate. So what our user does, he opens the browser on his laptop, heads to the Microsoft Online site, and provides the user code. So we see here, we are on the common IDP of Microsoft or of Enter ID. Next, there will be a question. Are you signing into this phone from standard or located in Switzerland? If yes, please continue. If not, close the browser. So the user enters their username, password, and if required, also a second factor. After that step, the user has also to give consent. So yes, I really want to log into the CL-Link phone, and I'm sure it's nothing bad. So, and in the end of this flow, all the user sees is an instruction to close the browser because the authentication has been completed. So in the background, our phone that was polling gets now some access tokens or access material to connect to different APIs or whatsoever they need to. So this access material, what might this be? So one, we have the access token and we have a refresh token. The access token is used to access APIs, such as Microsoft Graph or the discontinued Azure Graph, which I think is highly confusing because of the naming. And it's important to understand that an access token is always limited to one specific API. So you cannot use an access token that has been issued for Microsoft Graph for Azure Graph. By default, such an access token is valid for 60 to 90 minutes, and you cannot revoke an access token in Azure AD. So even if you disable the user, this access token is still valid. The refresh token, on the other hand, cannot be used to access any APIs, but is rather used to get new access tokens to then access APIs or whatsoever. Yes, and the resulting access token is, of course, bound to the same scope or to the same API as the refresh token is. A refresh token is valid for 90 minutes, But technically, you can just ask for a new refresh token, and it will be valid for 90 days again. And so you can indefinitely renew a refresh token. And on the other hand, or rather the opposite as an access token, you can revoke a refresh token. So now the question is, how can this flow be abused? So what it basically allows us to do is like we initiate a login flow on one device and finishing it on another device. So maybe some people already have an idea how to abuse this. Let's say we are a threat actor and we would like to read some mails of a Microsoft 365 account. If we Google a little bit, we find the MS Graph REST API description. We quickly find the get message method and the corresponding API call. And we also see that we are required to have the mail read permissions to access this API endpoint. If we enumerate a lot of applications of Microsoft, we come across the Outlook Mobile application that has this mail read permissions. So what we can do now is like, okay, we have MS Graph, we know this API call, we know we need the permissions mail read, and we know we want to impersonate the Outlook Mobile application. And that leads us to device code phishing. So as an attacker, we connect to the login site from Microsoft, and we state we are Outlook Mobile. We would like to access MS Graph. We will get a user code, and in a phishing mail, or we can start polling, of course, and then send a phishing mail, which might look like something like this. New file has been shared. Please use this code, which is the user code on the site, and then we have a link, which is just the device login flow link. And if the user does that, he has to perform the login, has to give the consent or 2FA if required, and if they are logged in, we can gain the access token and the refresh token, and then we can have access to the MS Graph API, where we, for example, can say, okay, show me all messages or all emails of that user. But what if we want to do also sending a mail as a victim, not only reading? If we head back to the graph descriptions, we quickly find also the send mail chapter and the required API call, but now we need the mail send function or permission. And if we check here our Outlook Mobile application, well, we are out of luck because there's no mail send permission there. So we cannot send an email over MS Graph by impersonating Outlook Mobile. If we look around, maybe we find this Graph Explorer, which has this mail send permission. And the big question is, can we now, or do we have to start our phishing process again, where we say, okay, we are now Graph Explorer, please user log in, and so forth. Or maybe there's a way where we can use our Outlook Mobile refresh token to gain an access token for Graph Explorer, where we then can send an email. This is usually not possible, because the refresh token is also bound to the initial application, so we are bound to Outlook Mobile. So if we request for the Graph Explorer on MS Graph, no, it's not possible. But Microsoft wouldn't be Microsoft if they wouldn't have implemented something quite awesome. It's called the family of client IDs. And what they basically do, I don't know why, they bundle some applications into a family or into a group of families, and each member of the same family can exchange their refresh token for another family member's access token. So we can't just say, and there's only FOKI1 at the moment, or group 1, at least that I'm aware of. So some of those applications, there's quite a list here. I have like the link to the SecureWorks research, but there's quite a list of applications that are in this family 1. And for example, the Microsoft Whiteboard client has the mail send permission. And what we can do now is we can say, okay, please give me a new access token for Microsoft Whiteboard client on MS Graph. And Microsoft will say, okay, it's in the same family. Here is your access token. And with that, we have now the mail send permissions to also send emails via MS Graph without doing another phishing. And even if the user just consented to the Microsoft or the Outlook mobile application, we also have permissions inherited from other applications. So just a quick recap, what are the advantages of device code phishing? So the victim authenticates on the real IDP site. So the HTTPS will be fine. There's nothing fishy going on there, right? So we also able to phish people that use like this YubiKey thingies because they authenticate on the right site. And I think this is awesome. With this family of client IDs, we have a wide broad capabilities to read stuff and send doing stuff. And as an administrator of a tenant of Azure AD, you're out of luck when you want to completely deactivate device code phishing. It's not possible right now. Like 2 weeks ago, Dirk-Jan posted some quite a nice blog post. And there in the end, he states that Microsoft is working on something, but until then, it's not possible to deactivate device code flows for their first-party applications. Even if they recognize that it is a phishing and they change the password or lock the user or whatsoever, you still have the access token that is valid around 60 to 90 minutes by default. So you can still abuse this token and have access to some data. If they don't recognize it, well, you can just refresh your refresh token indefinitely and have access to the account as long as they don't change password or do something with that account. And yes, Dirk-Jan also posted some other research where he was able to backdoor an account and register a Windows Hello for Business login credentials. And even if you change the credentials or something like that, you're still able to access all the data through this Windows Hello for Business credentials. Of course, there are some limitations that we have to talk about for device code phishing. The biggest one is the user code that we have to send the user is only valid for 15 minutes. So our attack frame is quite narrow. It's not something that you can just send out and maybe 2 days later the user will click. That doesn't work. And there's no, a colleague of mine calls it a happy flow for the user. So it's quite a bad experience for the user because at the end of the authentication, the user is just asked to close the browser and then nothing else happens. We also have conditional access policies that play a big part because they are applied to the flow initiator. And the IP location of the flow initiator, like here it's Switzerland, this is from the initiator of the flow. So if you have a device in Vietnam or somewhere else, then this location will be shown here and maybe it's suspicious to the user. So we had a red team engagement where we tried this device code phishing and we wanted to overcome 2 of those, or the first 2 limitations. And we decided to have a phishing website that does the initiation of the flow as soon as a user accesses the website. Of course, this has the disadvantage that the link in the mail points now to a phishing website and not to Microsoft directly, but it's worth it. And also, own phishing website allows us to do some happy flows for the user. So, for example, if now in our phishing mail we promised some data via OneDrive, we can provide that with this setup. Half an hour ago, I also released this tool called Token Fisher in our GitHub repository, which exactly does that. And with Token Fisher, an attack would look like something like that. We have our phishing mail where we say, hey, I want to send you some data via OneDrive. Please use this user code or access code to gain access to it. If the user visits the link, Token Fisher will initiate the flow for us, have the user code and pulse for the token. And now, towards the user or the user browser, we are setting a cookie, which is linked to the user code, and some instructions for the user what to do with that code. The user is redirected to the login site, does the login and consent and whatsoever. We get our tokens on Token Fisher. The user is instructed to close the browser. And what's the next thing the user does? If this wasn't successful, of course, they click the link again in the email. They land on our Token Fisher website, now with the cookie set, which is associated to a successful flow. And now we can just perform a redirect to some OneDrive shared folder where everybody has the link to has access to. And of course, we can then use these API keys to access the data. Now I would like to show you the demo where I would show you how to do that. Okay. So if anybody is interested in the demo, we just do it somewhere in the lounge or something like that. Yes. I've also released a second tool that I wrote rather badly, but it's out there. It's called Token Tormentor. And what it allows you to do is, as soon as Token Fisher finished the phishing attack, you have like these access and refresh tokens. And with Token Tormentor, you can do stuff like you could download all files of the user's OneDrive. You can download all the emails. You can send an email. You can also read all the Teams conversation that they have. Like it puts you like an HTML with the whole history, and you can like just scroll through and see if there's something interesting in there. You have the emails as EML, so you could easily open them in any email application. And you can also add an Outlook forwarding rule, so you have like some kind of persistence in the email of the account. All right, now we have 5 minutes. Okay, I was instructed to also include some what can you do about it slides. So access tokens, as I mentioned, you cannot revoke them. They are valid as long as they are valid, by default 60 to 90 minutes. But if you're lucky and you have a P1 license, there's a preview feature where you could reduce this time to like 10 minutes, but also there will be some variations. So it's like something like 10 to 15 minutes. You cannot go below that value. On the other hand, mitigating refresh token is quite easy. This is from this link here from Microsoft. We are here in this password-based token, and you can see here if you change the password by the user, all the tokens will be revoked. But this is not a valid option for all of the tokens that exist. So we always recommend to do it via MS Graph or PowerShell, and then you can revoke the tokens or all tokens that exist. And another nice thing to do is like you have conditional access sign-in frequencies. So let's say you require the user to log in every 14 days to their account, and then all the refresh tokens that exist before that will be invalidated. Detecting and preventing, well, as I mentioned, it's not possible to completely disable this device code flow for the Microsoft first-party applications. But what you can do is like you could set conditional access policies to only allow certain IP addresses. So the initiator has to be in a certain location, or reduce logins to only MEM or MDM managed devices, so like Azure joined or Azure managed devices. And you could use the sign-in frequencies. Detecting is rather simple. You have in the sign-in logs, you could just filter for device code, and then you would see if a user completed the device code sign in, and if that's not common in your company, then all your alarm bells should go on. I think that's the end. Yes.
Thank you very much. I'm so sorry for the delay. Thank you for compensating.
I had to talk really fast.
Yes, very sorry we couldn't go for the demo. Maybe there's a possibility to talk to Felix about it, or maybe he can show something. It's up to you. Yeah, technology is sometimes even surprising with all these experts in the room.
Of course, yeah, it is.
We have maybe time for about 1 short or 2 short questions. Are there any?
I had to reduce the slide deck from a 4.5-hour talk to 30 minutes.
Wow.
So there are a lot of technical details that I had to leave out, but I'm happy to talk about it. So.
I mean, we are a bit short in time.
For me, it's okay.
So if that's okay, I would kindly ask you to seek Felix out, maybe in the upper row. And
Yes.
I thank you very much for your
Thank you.
contribution.